Welcome, everyone. My name is Shayna, and I'm part of the RubyConf Programming Planning Committee. Today, we're delighted to have a senior Microsoft software engineer from Seattle joining us. Our speaker, a Ruby and functional programming enthusiast, has been in the programming world since 2008 and is passionate about learning new languages and exploring software engineering processes and organization. Let's warmly welcome Phil Crissman to the stage.
All right. Oh, thank you. Okay. Oh, not that. Hi, everyone. My name's Phil. I started in about 2008 with Ruby and Rails. It was like Rails 2.1, 2.2. I did consulting when I first started. Not really I'd say subcontracting. I made a lot of new Rails apps from the ground up. That was a great experience. In about 2013, I moved to Seattle, a short contract at Amazon, a couple Seattle-based startups, and then in 2015, I started at Microsoft. And yeah, for anyone who's too young to know, that was a real Microsoft logo at some point in the 80s, the most metal of all Microsoft logos. And yes. The part of Microsoft that I joined used to be a startup called Yammer. And so they were built on top of Ruby and Rails. They had a bunch of Java microservices, and they have kept that tech stack because it would have been crazy to rewrite it. So this is called How Programs Learn, what happens after they're built. I had a little clicker. Maybe I'll try that. It's not about machine learning. Oh, that goes backwards. Okay, I know how to do this. Sorry. So let's see. I'll start with a little preliminary stuff. There's a book called How Buildings Learn that inspired the title of the talk, a lot of the content. And in turn, I heard about that book through a paper from the late 90s called The Big Ball of Mud. And so that's where some other material for the talk comes from. And then we'll try and think about, well, given all this, now what? Oh yeah. There's our source material. Clicking is good. Who's ever seen this acronym? What does it mean? Mean time to failure. Yes, we get that from manufacturing, and I think kind of DevOps and compute have adopted it a little bit. Mean time to... So a little while ago, when I saw these, I thought of a metric that I like to use for my own code bases. And that is MTTA. And it started as a thought experiment. I imagined, okay, if we have a new person at work, or maybe there's someone visiting, someone I really respect, and it's my job to walk them through our code base. How long will that walkthrough take before I find myself apologizing for something? An apology in my head in this is very broad. It could be anything from we've really been meaning to refactor this, all the way up to, I'm sorry you have to see this, and I'm sorry it exists. And I realized when I thought of it, I don't know, a lot of code bases I've worked on, my MTTA would be effectively 0, because I would preemptively apologize for what I was about to show them. But I'm also Canadian, so that might have something to do with that. So I think right when I started, I also had the good fortune to learn about agile software development processes, because even the Rails book at the time was Agile Web Development with Rails. And I loved the idea. It made a lot of sense to me immediately. And this is sort of how I imagined our software would grow. It would grow incrementally, iteratively. Parts of it would be different, but it would all fit together wonderfully. It was all going to be beautiful. And I think how I really felt about the software usually was a little more like this. And then I got gradually to work on larger systems, and I felt like this is the goal. This is the world Kent Beck wants me to live in. And but again, the reality often felt a lot more like this. And you think of a new feature or a new thing you need to do, and you can draw it, and it's pretty and it's small, and it's simple. ChatGPT drew this, so some of the arrows don't actually connect, but let's imagine it makes sense. But again, the reality always felt a little bit short, and within a couple weeks of doing the work, I would take a look at it and be like, how does this even work? Well, the test pass. So, and one thing I really liked about that first 8 or so years that I got to spend contracting is that I got to be the guy typing Rails new a lot. And so I got to witness that exact moment when the code goes from something that's small and beautiful and fits in your head to when it doesn't anymore. And someone will come up to you and ask you, how does this work and what does it do? And well, I don't think anyone knows really. What is knowledge anyway? I mean, how do we know anything? So I mean, software architecture as a metaphor for building software is a long history in the software development, software engineering community. It's by no means the only metaphor for building software, and it's possibly not even the best one. But because of the source material I'm using, and just it's kind of certain architectural metaphors. We use the word architecture, an architect, for roles and for features of what we build. So there are other metaphors. People think of software sometimes as or more organic, growing like a garden. There's other ways to think of it, but for better or worse, today we're going to think about sort of as it relates to buildings. So this is the book, How Buildings Learn by Stewart Brand. And you can see right on the cover kind of where he's going with it. That's a photograph about 130 years apart. I don't know if the first one's a photograph or just a drawing or just a really old photograph, but it's the same two buildings in New Orleans, about 130, 40 years apart. And you can see they've both grown and they've both changed. They haven't changed the same way. And that's kind of an ongoing theme of his book. So Stewart Brand, real quick, is mostly known for the Whole Earth catalog. He's written a lot of books over the years, and he's always kind of had his one foot in kind of Berkeley 60s counterculture and another foot in technology and the development of new things. So the themes in his book, a lot of them have to do with adaptations, how buildings do or don't adapt easily. Time layering, different layers of architecture change at different rates. Your structure hopefully will stay static for a long time, but what is inside that structure can change at different rates and with different levels of difficulty. Oh, whoops, I forgot the last one. Piecemeal growth is the other thing he talks about. When buildings do grow, they tend to grow incrementally over time. So this is a church that was built about 800 years ago. It's in the Netherlands, and it's a bookstore now. But over its history, it's been, if I remember correctly, it was a warehouse. It was I think a printing shop. And at one point, according to the source that I had, an actual bike shed, which is kind of fun. So Brand tells us in the book, he says, almost no buildings adapt well. They're designed not to adapt. This is a building, I want to say Suffolk. It's in England. It's pretty clear this was originally a water tower. And I guess at some point the water tower was no longer needed and someone decided, what the hell? This could be a house. And it seems to have worked, but at the cost of, it's an unconventional house. The time layering, Brand uses the term shearing layers, which will come up again. And he uses that, he makes this statement, because of the different rates of change of its components, a building is always tearing itself apart. And the diagram is great because he uses kind of the thickness of the line to show how hard it is to change the thing, and then the arrows and the number of arrows to kind of indicate how frequently might you need or want to change that thing. So there's clearly some parts of a building that change very slowly, if ever, and other things that change frequently, And fortunately, most of those things are also easier to change, like the stuff inside your building. So Brand got this, this idea of layers from an architect named Frank Duffy. And he quotes Frank Duffy as saying, the unit of analysis isn't the building, it's the use of the building through time. Time is the essence of the real design problem. Here's what we're building today, what we're going to need in the future. He identifies a couple different categories of architecture, not in the sense of like Georgian, Victorian, modern, but he has this concept he calls low-road architecture, what he thinks of as like, you think office parks, industrial warehouse space, cheaper to build, much easier to change, almost it's designed to change, versus what he calls high-road architecture, you know, meticulously designed, very beautiful, but very difficult and expensive if you ever want to change it. So this is also a different shot of the first photo in the previous slide. This is a building in MIT, was a building in MIT called Building 20. It was considered a temporary structure, and so they didn't even, it just was always just called Building 20. It didn't even get a name. It was built in the 40s, I want to say 43, as a place for radar research in World War II. And it reportedly was designed in an afternoon and built in 6 months. Yeah, and the temporary building, it lasted for 55 years. And you can see, this is a shot of one of the hallways. You can see all the pipes, the wires, the conduits, they're all exposed. And after the war, the students and faculty who took up residence there, they considered that a benefit because they were easier to access. Students called the building the best experimental building ever built, because if they wanted to cut a hole in the floor, they could cut a hole in the floor and nobody cared. If they wanted to string some wires from one place to another and they had to cut a hole in the wall, they just did it. And interestingly, as a historical artifact, the Tech Model Railway Club at MIT, which is, if you've read some of that history, it was a precursor to the early MIT computer hacker culture. They were housed in Building 20 because it was a place they could build their things. This is a library in Boston called the Boston Athenaeum. I don't know if I'm saying it right, but. And it's been there, I think, since at least 1915 or maybe earlier. In the book, Brand has some photos of this room. This is one of the reading rooms. And they're about 40, 50 years apart. And they're, other than slight movements of the table and chairs, they're identical. The building has not changed. Turns out if you know exactly what you want and are never going to change your mind, big design up front is just fine. The problem is we rarely have the luxury of knowing that. And you can imagine, if you ever had to repurpose this space, how would you even approach it? It's built to be a library. It would be difficult to repurpose it. One more real quick. This is another building at MIT. It was designed by an architect named I.M. Pei, is a famous, renowned architect. But Brand says, from his understanding of how this was built, there were problems with the planning with the faculty and the architect. At first, he says the researchers were too vague, because it was intended to house what at the time, this would have been the 80s, the MIT's Media Lab. And at first, they were too vague, and then later they got very specific and wanted rooms designed exactly around the research they were doing right then, with no real thought for how the building might be used in the future. And Brand tells us that as a result of that, like, there's a lot of just spaces in the building that are unusable and not very conducive to being occupied by people. Piecemeal growth is another thing he talks about, and I think we see this in software too. Things grow and grow and grow, but there's not necessarily a plan. Like with a house like this, the final vision is not what the original occupant of the house probably had in mind. They just needed an extra, maybe that was a kitchen, maybe it was just an extra room. And I think that happens with our software too, and then we're burdened with the choices that we made in the past. And Brand says buildings are a prediction, and predictions are always wrong. And it's interesting, if you've ever read, there's a couple software architecture books by, I want to say Mark Richards and Neil Ford, and they say almost the identical statement about software architecture. Architecture is a prediction, and we tend to be wrong. As he gets further into the book, of course, he starts looking for solutions to all the problems that he's kind of talking about. And he tells us buildings can be designed so that it doesn't matter when they're wrong. And that makes my software engineering ears perk up. I say, oh, really? Tell me more. One of the things he talks about is scenario planning. With scenario planning, they try to figure out not just the one thing, but the several things that they might need to do in this building. And they try to design a building that would accommodate all of those. Problem seeking is a book in the architecture profession. It's a procedure for working out with the client. What do they need? What do they want? What can they afford? He mentions the iron rule of planning. Whatever you think will happen won't. Whatever you're ready for doesn't happen. And whatever you're unready for does. This is some drawings of an actual kind of that exercise of scenario planning for a film company. So they decided on the y-axis there, they had, well, our company might stay small or it might grow large. And then on the x-axis, they put kind of the market conditions. Well, the market might be stable, the market might fluctuate. And what would these lead to? And what they decided was at the bottom right corner, if they grew large, had a big building, but then the market suddenly tanked, is the worst possible case. They did not want that. So they decided to target staying small, fluctuating, kind of the top right, because they figured, hey, if the market's stable, great. And if we have to grow our company, that's also fine. We can just grow into these other small buildings around us. We can grow that way. We don't need a giant building. I imagine there's some companies post-pandemic who are wishing they didn't have a giant building. Another thing he talks about in building with change in mind is, and again, this is building specific, but I think we can, for me at least, it spurs some thoughts about software. He says, you don't have to hide your services inside the walls. Then if you want to change the services, change your wires, change your pipes, you need to open the wall. And there's a term it reminds me of in software. Does anyone know the term connaissance? Connaissance essentially just means if one thing is connaissant to another, if I change the first thing, I also have to change the second thing. And we want to minimize that. You also hear the terms like coupling. Another name that comes up a lot in the book is Christopher Alexander, who's also an architect. He wrote a lot of books. He wrote this particular one, might be the most famous. These, I believe, are patterns for exterior spaces, for gardens. And his work inspired, in part at least, design patterns that we still talk about today. And one of the things Christopher Alexander said about buildings is he felt buildings should be designed to last 300 years. And so that makes me think a little bit about how I design software sometimes. So in the late 90s, there was, kind of related to these patterns idea, there was conferences called the Pattern Languages of Programs. And in 97, Brian Foote and Joseph Yoder submitted a paper there called The Big Ball of Mud. And I had heard the term, I imagine everyone's heard the term, but I had never read the paper. I assumed that it was just kind of a jokey name for software we thought was bad. And it kind of is. There's some humor in the paper, but they're also, they're fairly serious about what they're talking about. Their main point is, okay, we've got all these software engineers, and they're all smart, and they come to conferences like Pattern Languages for Programs, and they care about design. They know the design patterns. They know about object-oriented design. They care. Why then is what we see in the world most often a big ball of mud? Because it's made by the same people that we know all these things and care. How does this happen? Why do good developers make bad things? And They explore that in quite a bit of depth. It's somewhat humorous to read, but they're also serious, because they're basically saying, hey, this happens. This is what we see in the wild. And we're the ones making it. Why? How? They identify what they call some forces at work in the development of big balls of mud. It's time, cost, experience, skill, visibility, complexity, change, and scale. So time and cost, are probably the most familiar and maybe biggest forces that are usually at work. Deadlines, whether they're self-imposed or externally imposed. Sometimes you have to sacrifice something you would like to do in your software because it needs to be done. And then cost may or may not also have to do with time, but it may just be, to design this and make this the way we want is going to take too long, and that's going to cost too much, and we can't do it. And so sacrifices are made, compromises are made. They bring up experience and skill, and they don't necessarily just mean inexperience, like someone's writing bad code because they don't know what to do. It's more, there's different levels of experience on any team, and all of the code that all those different levels of experience and different levels of skill produce is all coming together and coexisting. And the experience doesn't even necessarily mean inexperience writing software. It could mean, I've been doing software for 15 plus years, but if I join a fintech company, I have zero experience with the financial domain. And I'm going to need to ramp up on that if I want to be effective in that environment. There's an old quote from the first edition of the Rails Way. They had a technical reviewer, and his comment on this was in the section in Active Record where it talks about doing includes on another model to avoid N+1 queries. And he said, let's let people learn about eager loading by crawling across broken glass, like we did. It builds character. And for some reason that stood out to me so much, because it made me wonder, are there things that I have to do wrong in order to learn the lesson? Like, do I have to make the mistake in order to learn? Is this person right? And I think they were just trying to be funny, clearly. But it did make me wonder, and I hope that that is not true. Because if all of us need to learn the same lessons by experience over and over again, that's going to not be good for the overall development of our industry as we go on. If every new software engineer, every generation has to learn from scratch why connaissance and high coupling is bad by doing it wrong, that would be unfortunate. This is the aspiration. This is a poorly drawn lines by Riza Farzamand. This is my highest aspiration. I want the mistakes I make tomorrow to be different mistakes than the ones I or we made yesterday. There's visibility, by which they mean, the code itself, this ugly code that we don't like. The user and the customer and the senior leadership and the product manager, they don't see that. All they see is the code works, let's ship it. And then complexity, reams have been written about complexity in software and how it is just one of these things that we have to battle. We all like the idea of code that fits in our head, and dread having to work with something that we know is not going to fit in our head. Another book I like called Design of Everyday Things by Don Norman, and that's a great book also. But he says complexity is essential. In other words, some things are just complex. If we're doing, again, maybe fintech, or if we're doing, certain domains simply are complex. He says it's confusion that's undesirable. If you can hide that complexity or make each step of the complexity simple, that's what you want. You want to be able to look at something and know what to do and not be confused by it. This is a real comment in a code base that I worked on. And I know we all believe that, we should comment our code sometimes. It can be helpful. But by the time I read this, Git Blame told me it was 11 years old, Zach was gone, and the person who wrote the comment was gone. So I was left wondering, does Zach know what Zach is talking about? Was this cool? Should I be worried about the lines of code that follow this? But there's no one to ask. That's probably not what we want. Change and scale are the last things that they talk about. And the whole agile process, Kent Beck's Extreme Programming Explained has the subtitle, Embrace Change. Our processes are designed to help us deal with change and help us roll with it and help us manage it. And then scale. Scale, I feel like, becomes a problem on both ends of the spectrum. When we find out we need to scale and we're not ready to, or kind of like Matt said in the opening day, we decide probably we're going to be Google and we should design scaling in right now when we don't need it, and we wind up with overly complicated code. And when we actually do need to scale, maybe it's going to be something different, and then we're just stuck with this thing that would have been fine. I think we do that a lot. What time is it? So Brian Foote, one of the authors of the paper, he gives a talk. It's on Google Talk, so it's on YouTube, and it's worth a watch. But he tells a story in there. He used to walk to work, and when he would walk to work, he'd walk through a residential neighborhood in Silicon Valley, and he said one day he was walking past a house that was lifted up from its foundations, and they were working on the foundation. And he related, like, wow, that's so much work. That looks so hard and so expensive. I'm so glad I work with bits and software where things are simpler. We don't have to do stuff like that. And then he went back to thinking about his project, and he walked back and forth on that street every day on his way to work. He says on the third day that he walked by, they were done. And he said, he realized, oh, what I'm doing is actually more complex and more expensive. Maybe that would be better. So they identify some patterns, or could be anti-patterns, in the paper. And that's, of course, the big ball of mud itself, just this big spaghetti code jungle that we deploy. Some contributing patterns to that they identify as what they call throwaway code, which I'm sure we're all familiar with. A quick solution that we're sure we're going to be able to go back to and change later, but then becomes a load-bearing piece of our infrastructure. Piecemeal growth, of course, similar to what happens with buildings. So we're going to grow, but we can't do it all at once. We can't plan it all at once. We'll tack a little piece on at a time. Oh, sorry, I forgot to click. Piecemeal growth, and keep it working. A hot fix, similar to the throwaway code, but it's just something, it's maybe a little more urgent. And again, it rarely gets refactored into maybe the form that it should be. Shearing layers is the other pattern that they mentioned, which is based on Brand's concept of layers of a building that change at different rates. And their recommendation is, why don't we try to keep things that change it in the same rate together? Which sounds like a great idea, but I also think is easier said than done. Sweeping it under the rug is the pattern where something is just so complicated and so maybe fragile that you decide, you know what, let's just not touch this. Let's maybe put something in front of it, and we'll talk to it through the thing that's in front of it. That can work all right, except that you haven't done anything with the complexity. So if you ever do need to change it or maintain it, it's all still there. And maybe even scarier because no one ever touches it. And the last pattern that they mention is, of course, the we give up, rip it up and start again, rewrite. So Paul Buchheit, some people might know the name, he was an engineer at Google. I believe he led the effort to build Gmail. And he had a blog at one point, and I vividly remember a post that he wrote. He said, everyone knows that perfect is the enemy of good enough. That's the way he phrased it. Perfect is the enemy of good enough. He said, what I've realized recently is sometimes good enough is the enemy of at all. And I felt like, well, that seems a little profound, but then I also felt like, are you saying we should ship stuff that's not even good enough? And yet we do, so maybe he is. And that reminded me, and Foote and Yoder also reference, there's an essay by a fellow named Richard Gabriel, who's a Lisp programmer, again from the 90s. And He was writing about why Lisp seemed to be losing. And he contrasted two software development ideas. One of them he called the right thing, which he also identified with MIT and Lisp and Scheme. And the other he called worse is better. So the right thing, the most important thing is correctness. Both systems care about the same things. But in the MIT way, as he identified it, nothing trumps correctness. If you have to make it less consistent or less complete or less simple, simplicity was at the bottom. You want it to be simple, but if making it simple sacrifices one of the things above it, you're not going to do it. He contrasted that with worse is better, which he identified with Unix. He said, in this way of developing, simplicity actually seems to be the most important thing. And other things can be sacrificed in favor of simplicity. And then after that, consistency. We want consistency, and so on. And he said, he believed that the right thing, the MIT way, the way he had kind of come up in software, was actually the right thing. But then he goes on to say, but I think the other way is going to win. Because they're getting software in front of people faster, and then people are using it, and people buy into the ecosystem, and they can fix it later. And I think that is what happens, what has happened in a lot of parts of software, and the reason we keep pushing big balls of mud into production. Kent Beck told us the way to build software was to make it work, make it right, and then make it fast. And I feel like we've all had the experience of, well, you make it work, but then you move on to the next project. But wait, now we have a customer escalation, and actually we need to go back and make that thing fast now. We haven't refactored it yet, but it really needs to be fast right now. Great, awesome. Now there's another project, by the way. And now if you're extremely lucky, maybe you get the opportunity to make it right, except that by this time, you and others have built on top of it, and now it's hard to change, and maybe it doesn't even get changed. So given all these forces, is the big ball of mud inevitable? I hope not. I do think from history and from the places I've worked, and I don't know if this rings true for everyone else, it feels like sometimes, especially in the early days when you need to get a product in front of users who are going to pay for it so you can keep your lights on, sometimes it might be necessary. But we don't want to keep it. So what can we do? I think one thing we can do is simply have these conversations. Have a book club where we talk about things like this. Because it feels like one of those things, if you don't talk about it, it's very, very easy to just move on to whatever the next quarterly goal is. And to let these things, slide. Oh, I left this slide in. Do I have time for it? Okay, there's a formula I found in a book called Improving Software Development Productivity. And it's a pretty dry book. I'm not sure I recommend it, but there's a few interesting nuggets in it. And one of them is this formula. They call it the effectiveness formula. And they basically say, okay, net effectiveness is going to be the multiplication of your communication, your team's communication ability and skills, good management concept awareness, and technical ability. So in other words, if you're at, the top percentile in each, they're still multiplicative, and your still overall effectiveness is 73%. If any one of those is, you can imagine a situation where everyone communicates great, and your technical ability is top-notch, but the management is terrible. That drags everything down because it's multiplicative. And in this example, I chose to just leave technical ability and management kind of concept awareness near the top, because ultimately, they're not things we can change quickly. I think we're all always trying to improve our technical ability, but I can't just wake up tomorrow morning and say, you know what, I think I'm going to be a 5 times better developer today than I was yesterday. That takes time. And similarly, we can't change management. We can, at least not quickly. But I feel like in some ways, there's also a process of learning communication, but it is something we can choose to do. It feels like it could be done a little faster. I could just choose to communicate more often. I was talking, one of the benefits and drawbacks of having a badge that says speaker on it is everyone asks, what are you talking about? And so I've had a chance to talk to a lot of people about these things in the last few days, and one conversation I had with someone said, I think it's kind of a social problem, and I think it is. If we don't talk about these things, if we don't, Rich Hickey, I think, gave a talk. He's the developer of Clojure, where he said, really all I want after this talk is for you guys to go back to where you came from and talk about these things. So the global forces, if it's true, and it rings true, that these are what drive us toward big balls of mud, if we always just capitulate to the forces, we will always have a big ball of mud. Somehow, in some way, we need to push back at least a little. Otherwise, if their thesis is true, we will just always have big balls of mud. If we never try to push back on any of these, if we never try to manage them, whether it's mentoring, trying to level out, trying to let the more experienced people help the inexperienced. If management thinks we need to ship because they don't see the ugliness, is there a way we could make the ugliness visible, whether it's a metric or something, and so on. Scenario buffered strategy, I think, is a really interesting idea. But I think we all know if we bring up too many options, that butts up against, someone's going to say, you're not going to need that. And they might be right. And it's difficult to tell the difference. And I think that's one of the reasons we want to know our tools, whether it's OO, if we work with a functional language, the functional things, our own language, idioms and libraries, community libraries. Because that way, when we do have the opportunity to change our code, or if we do have a little time, we can design it from the outset to be something that we can be more confident has the ability to change, has the ability to stay simple. Ships, ocean-going ships have maintenance logs. Shore services have maintenance logs. I heard Stuart Holloway, who's another Clojure guy, in a talk, he said, what we really produce is not code, it's decisions. We write the code because we made a decision on what the code should be. But then, is that decision get documented anywhere? Like later on, when someone goes to look at that code, do they know why you did it? And he recommends something like a decision log. I've seen teams do that. You could put it, if you are going to keep discipline about it, you could put it in your PR commit message. You could add comments that are better than Zach said this was cool. But I think there's times that would be invaluable. Has anyone heard the analogy of Chesterton's fence? Yeah, I see a few hands. So G.K. Chesterton was a writer, I think a theologian in the 20th century, and he had this analogy we've taken to calling Chesterton's fence, in which he basically said, if you don't know why the fence was put there, you're not allowed to take down the fence, because it might be needed. You actually don't know. You can't take the fence down unless you know why it was put there. Once you know why, maybe you know it's not needed anymore. But until you know why, you don't know that, and you shouldn't take the fence down. I feel like we have usually two time horizons in mind when we write software. It's either temporary and we're going to throw it away immediately, or it's going to live forever. And I think it's probably both are wrong most of the time, especially the temporary things. As we've already talked about, they tend to just become part of the infrastructure. And then, the permanent things are never actually permanent. And we don't always plan for that. We don't always think about, okay, what happens when this dependency that I've built everything around is no longer maintained? What happens then? So yeah, back to how buildings learn. He talked about these sort of problems. In some way they're problems, some way they're just observations. Buildings are hard to adapt. They change at different rates. They grow at different rates. And some possible solutions, and of course his solutions are tailored towards buildings, because that's what he's talking about. He didn't write the building about software, but I can't not think about software when I read it because so much of it feels applicable. And I don't think we can give like a one-size-fits-all. It's because, go home and do this, and now you're, like Fred Brooks said, there's no silver bullet. I think for years, I just thought that there was. And someday I was going to find the secret sauce that the good developers knew that I didn't know. And I eventually realized, well, yeah, there's things, there's design, there's better design that I can learn, but it's still not going to magically keep our software from turning into something we would feel the need to apologize for when we show it to someone looking at it. So that's what I got. Thanks, everyone.